Hey guys. So I've been working on a little game here with the SDL2 library, Simple Direct Media Layer. So it's not a game engine. But it is a library that makes things a lot easier when developing games. But it doesn't have, at least not that I know how to use well, collision detection and that kind of thing. What it is more is just getting graphics and audio and different media onto the screen to display them. But then as far as like the game engine goes, that's all pretty much programmed in C++, and the one that I'm doing. You can SDL you can use a lot of different languages with it, but I'm using C++, and this is what the kind of thing that you're going to run into, or that you're going to have to think about, that you're going to encounter if you decide to make a game without using a game engine. So this is the code for a game, just a little game I'm working on just for fun. Let me start the game here and I'll let you see what it looks like. You ready for some phenomenal graphics? Oh yeah, that's it. MS Paint, Microsoft Paint. If you're looking for, some high quality graphics manipulation tools, some pixel art magic, yeah, MS Paint. So anyway, this is what it is so far. Basically, this is grass. This light green, this dark green is a hedge. This white-ish cream color is a house. The red is a door. The blue is water, and this is a road, the gray. So right now, I have collision detection working in a weird way because I'm in the middle, literally in the middle of setting this stuff up. And I thought this would be the perfect place to show you guys this, to give you an idea of exactly what it's like to create your own game engine instead of using one for your game. So I have this invisible object that I've been using for testing. It's in my code here. It is just called collision test rect, and you can see it's like 100x, 100y, and it's 100 wide and 100 pixels high. And so it's like right around here, and you see I'm still holding the down key, but my guy, he is not moving down any further. Same with like over here. Oops, nope, it must be down a little lower. Or my right, yeah, there we go. Okay, so right, and then if I go up, he stops. But if I go left, I can go right through it. And that is because my left collision detection is at the next stage of collision detection that I'm working on. So it's past me using this little test rectangle, and I'm at the point now where I want things to actually collide with the map, with objects on the map. So I'm looking at the tile map, and right now what I'm checking is, does this XY coordinate that the player has, which is this top left corner, does that collide with something that is solid? And things that are considered solid are water, the hedge, the house, and this door. The grass and the road are considered not solid. So you can see if I move left on grass, I can move left just fine. If I move left on a hedge, I stop. I'm still holding down the left key, but my guy is not moving. So now this is where the collision detection still needs some work. I'm just detecting in this top left corner right now. I need to also detect in this bottom left corner. And so right now, since I'm not detecting in the bottom left corner, if that top left corner is above the object, there's no collision there. If it's below it, there is. If it's above it, none. So that's where we're at. So let me show you some code now. So you can kind of ignore this collision class and object. I'm not using that just yet. And trust, this is spaghetti code right now. This is a mess because basically what I'm trying to do is get this working first and then refactor it, just because it adds a layer of abstraction when you use classes and objects, and I feel like where I'm at right now, adding that layer of abstraction is it just complicates things more. So I want to get this figured out first, and then I'll refactor it and break it down, make it a little prettier, easier to troubleshoot, and easier to work with going forward, that kind of thing. So, but anyway, so we have our main file here, the game file that runs, it has our handle events function or method. So here's where it's handling key input. If SDL detects that there's a left key being pressed, then it gets this player, which is an instance of the game object, as you can see there, and it uses the move function, which is a function of the game object, and it gives it 4, which is a code that I have coded in here, meaning that's translated to left. So then here's that move function. So if direction code, which is what we fed in there, right, is 4, then we're moving left. So then we're going to look for collisions on the left side. And so let me show you I want to show you a diagram now before I get too much further into the code. Here's something you'll be thinking about. This is the kind of thing that I've had to think through while making this game without using it, since I'm not using a game engine. And SDL may have something like this built in somewhat, but I'm just completely winging it here. This is just completely just for fun. I'm not trying to do anything fast or awesome or perfect. So this is first of all, you can see here's where I started thinking about collision detection, and that was a couple weeks ago. And a lot of pages later, and I don't use this to take notes or remember things. I just write down stuff to think it through. It helps me think. So that's just how I think, kind of. So yeah, so a lot of pages of thinking there, and that's a lot of that is front and back. Not all of it is, but I think every other page pretty much. Good amount of it is. So anyway, I have this little diagram that I want to show you one thing that really stumped me for a long time with collision detection. And so what would happen is my player would, I would want to move him left, but collide. He would collide with an object. So this is the player, this is the object. Say we collide. But then when I was colliding with that object, okay, I would stop him so he couldn't move. So that was good. He couldn't move left. But he also couldn't move up. And the reason that is because, so here's this T stands for tile. It's a water tile, we'll say. And this is the player tile. So that's our player. When we're detecting collision, we're detecting it in this upper left corner and the bottom left corner for leftward movement. Now, you have to detect collision before you let the player move in that direction. So when the left key is pressed, before you let the player move from that key press, you got to check for collision. Because if you check after it moves, if you move and then check for collision, then what you end up having is you have a collision already. So this is the example where we're checking for collision after we move the player. So we have a collision. So what happens is this left corner is used for collision detection in both left movement, right? Because for leftward movement, we want to check these two corners. And for upward movement, we want to check those two corners. So since the collision happens already, we cannot move up or left. Even though the player should, you would think, be able to move up. Like say there's a wall here, and the player's colliding here. You would think, okay, well, he should still be able to move up because he's just moving along the wall. He's not trying to go through it. But it doesn't work that way if you check for collision after the player moves. So you got to check before. So if you look at my code here, I should make this bigger here too. Oh man, how do I make this bigger? let's just try Control plus. That can work? No, that didn't work. Okay. So, maybe I can zoom it in. I don't know how to do this, make it bigger for you guys. So anyway, let me just explain it here, I guess. But so we gotta get the key input and say, okay, it's a left key input. So then we have if direction code equals 4. I apologize, this is small. Next video I'll do it better. Then we check for collision, and then based on if there's a collision or not, and if the object that it's colliding with is solid, then we either allow movement or we don't. But when I'm checking next tile, you can see I'm doing X position -2. That means this position minus 2 spaces. So we're actually checking, is there a collision over here, instead of checking we're checking is there gonna be a collision rather than is there a collision. And by doing that, then we can say, okay, if there's gonna be a collision, then stop the leftward movement. We don't want you to move left. And by doing that, then we prevent a collision, so then we can still have that upward movement. So this could still move up along the wall because it hasn't collided, so this corner isn't in a collision yet. So yeah, so that's the kind of thing that you're gonna end up thinking about if you make your own game engine, which, you know, some people like that and some people don't. Some people want to spend a couple weeks just figuring that out and learning. Like I've learned a lot about C++ doing this, a lot. And some people would rather just, you know, make a game and get to the end product, or, you know, create the art for the game and have to do as little coding as possible. If you use a game engine, you're still going to have to do, you know, there's still going to be some collision functions that you're going to have to use, but a lot of the code is going to be written for you, and it's going to be a lot more optimized, most likely, if it's a mature game engine. Yeah, so right now where I'm at here with the collision detection is we check, is there a collision, or will there be a collision? Okay. Actually what we're checking is what's the next object that the player is gonna overlap with, right? And then we check, is that tile solid or not, basically, is what I'm getting from this map. I'm getting a lot of other data, but the only one I'm using right now is the map tile type, which is, you know, is it grass, is it dirt, is it a hedge, is it water? And then based on that, so if it's a right here, if it's case 0, which means it's water, then, and you can look at my tile map and see, this is, all these zeros are water, 0, 0. And if we look at my game, you can see that's where all the water's at, right there and right there. You can see the 6s are the house. So yeah, so if we go back into our game object, you can see if the case is 6, then it's house. So anyway, if the upcoming tile is going to be water, then we need to check, is there going to be a collision? This is where we check, is there going to be a collision? Because if there is, then we need to set the velocity to 0, which means the player no longer has, you know, it's like setting the speed limit on a car to 0. If you set the speed limit to 0, it stops going, it stops moving, right? So this is just checking if the X position moves left 2 pixels, and if when it does that, then it's greater than the next, the solid tile, you know, basically the solid tile, or equal to, and this is just figuring that out, then we set the velocity to 0, the X velocity. Otherwise, we just leave the X velocity to 2, or we set it to 2, and that's where, and this is where we say, okay, the position equals the position minus the velocity. So the velocity is either 0 or 2. So it's either moving or it's not moving. Now what I need to do is add some more into this if, or or maybe add an else if. I haven't really thought too deeply about it yet, but something that will not only detect collisions in the top left corner of the player, but also in the bottom left corner. So I know that's, I might have done a horrible job explaining that, and maybe you just completely didn't understand anything I was saying. I'm not sure, but the whole idea of this video is that I thought, a lot of people will say, you can go on Reddit or Stack Overflow or whatever and say, like, what are the advantages of using a game engine versus not? And you get a bunch of opinions and stuff, and one of the most common things you'll hear is that if you use a game engine, you're going to save a lot more time. Now, if you don't use a game engine, the biggest advantage, I think, is that you're going to learn a lot more. It's like when you install Linux, people say if you want to really understand how Linux works, you install Arch Linux, which is like installing Linux from a very minimal installation and setting a lot of stuff up on your own. Rather than if you just want to get working with Linux, then you install like Ubuntu, which already has, everything's going to be pre-configured for you. But so that's very much what it's like. So, but instead of just telling you, I wanted to show you, because then it gives you an idea, not just that you're going to be spending more time on creating the game engine or on creating the game in general when you're not using an engine, but I also wanted to show you exactly what kind of thing you're going to be spending the time on, because that's important, right? What you got to think about, what would I rather spend my time on? Would I rather spend more time like maybe getting nice artwork that I make with Sprite or something, or would I rather spend more time, fidgeting around and just having fun and learning code and learning C++ or whatever programming language, and learning how game engines work? So, or would I rather spend time learning a specific game engine, and that's going to take a little less time? And yeah, anyway, that hopefully this gives, hopefully it helps you out, gives you some ideas. And anyway, thanks for watching, and peace out.